at this point, we've pretty much covered everything there is to cover about this mesh stamps node. I've now explained how it goes about creating this stamp. Now let's switch to the next stage and actually show you how to integrate it with the rest of our terrain. Because ultimately, you will need to understand how the road terraforming works, at least in basic terms, so that we can then stamp on top of that. So let's go over to Houdini, to our main project here, and let's see how this is accomplished. Now, if you look at the example asset, you will see that we have a PDG and presets section here. Now, I've already gone over this a little bit before, but what we're going to do is we're going to add a new task for our task manager that we can run subsequent to the road terraforming task. So if we zoom in here to one of our villages, you will see that right now all of our terraforming here is included with our terrain. Now, if we take a step back and we go to the previous node, you can see here that we have all our road terraforming, but none of the buildings. And that's because we're computing this in stages. Also notice how this particular terraforming node is only running on one landscape. If we were to look closer here, you'll notice that the roads abruptly stop once they go too far outside of the left landscape here. And that's because inside the PDG, I'm computing one landscape at a time. I'm not computing both. And I'm doing that to save memory, because ultimately, the bigger your landscape, the more pixels you need to process, and the more heavy modifications you're doing to your height fields, the more memory this is going to take. And a very large landscape in Houdini with a lot of modifications is going to cost you a lot of memory. Even with my 128 gigabyte of memory and a lot of page files set up, this is going to be quite heavy on your system. So being able to split it up into multiple landscapes has its advantages, right? Because we don't have to process both at the same time. We can stagger this process, which is what I've done over here, in fact. So if we have another look at the task manager, notice how I can tell it to only compute landscape 1 or compute landscape 1 and 2. And then I also have this mesh stamps option behind it right there. So this is me controlling how the PDG goes about re-rendering out my landscape tiles. Let's have a closer look. So if we go to our task manager here on the left, if we go to our compute terraforming node, which is where we deal with all the road terraforming, I have a network set up that handles all the terraforming tasks for our landscapes. We could compute the entire world, all the roads, all the mesh stamps, and the overlap tiles via this network. It does that by running these HDA processors, which are processing one of our nodes, one at a time. So here, for example, I'm processing the step 1 roads PDG node. Basically, this node right here. And following that, we can process this second node for the mesh stamps as well. If we go over to that, that's this node right there. Now notice how both these nodes internally have the same settings. We can tell it which landscape to process. If I don't want to process landscape 1 on top of my PDG node, I can actually tell it not to compute this one. Doing that will bypass both these landscapes internally and only just pass the data right through these nodes, right? So at that point, both of these are ignored. It's going to pass that data through and only compute out landscape 2. So I can control what it's computing. Likewise, if you don't want to see the mesh stamps in your world and only have the road terraforming included, you could go ahead and disable these. That will bypass these HDA processors. Okay. Now the way how the PDG works is that each node is going to take its data and then send it as a task through to the next node. And with those tasks, it also includes some input files. Specifically, it's going to output the data to a cache file in the geo folder. In this case, that would be the massive worlds folder. So if we look at that, we look at the massive worlds folder and then geo, here are all the caches that the PDG normally outputs. So for example, this particular file here is the file that was written out by this terraforming node before it is passed to this guy, which then takes that data and continues editing it. It's kind of like plugging nodes together, but it's caching that data intermediately. Anyway, after this, the data gets pulled together, and then it's going to end up at this node here, which is going to run the batch tile exporter, which will render out all these tiles to the tile folder. After that, we also run the overlap tiles, which is the last process in the chain, which handles the extra tile that's necessary to make two landscapes seamlessly connect and to remove those annoying edges that you might get at the edge of a landscape, because that's just the way how Unreal's landscape system works. You need an extra pixel at the edge of each respective landscape, otherwise you can't write to it. And to do that, I create these extra tiles, basically these tiles, which represent that final pixel. Overall, it's a very straightforward process once it's set up. So internally, I'm going to run the overlap tile processor, and then after that run its exporter. But anyway, now that you know how this works, at least roughly, let's have a closer look at the terraforming nodes for the roads and for the mesh stamps. Because ultimately, we need to pass some data from this node here to there to continue editing our landscape. Let's have a quick overview on how this works. Let's go over to the work scene here again. And I'm going to have a closer look at these two nodes here. Now I'll give you a quick overview on how the road terraformer operates. So over here on the left, we can see we have all of our landscape data currently being output, and this is ready for editing for our mesh stamp node. Now at this point we don't have our mesh stamps yet. This only includes the road terraforming itself. Now the way how this works is at the very top of the network we have our process and export tiles nodes. These are the main nodes for the toolkit. And these nodes are currently pulling in our BGO files that were extracted from Unreal, right? So this guy's pulling in landscape 2, and this guy's pulling in landscape 1. And both of these are configured to import the landscape data with the edit layers as well as the material layers. And it also tells it which material layers are weight blended and which ones are not weight blended. This has to do with how the material system works, and I'll go over that in a second. Then next to that, the node has the ability to output a preview of your terrain with a certain layer. For example, here it's currently saying exposure, which has no data. So let's grab, let's say, the darken layer. Here you can see the data that was pulled in from Unreal for the darken layer. Alternatively, we can have a look at the, let's say, auto forest layer, which describes everywhere that our terrain has the auto forest material. Just to explain, this is a auto material that automatically assigns cliffs, it assigns the grass, and in some places these little bold patches in the forest. Next to that, if we get closer to the water, it's going to create a beach, and if we get too high into the mountains, it's going to add snow. So that's the basic material for this terrain. Now next to that, we also have the desert material over here, which has a couple of varieties of dunes and sand, and then also these rocky cliffs, right? And finally, you'll notice that there's some darkening here. That's the darken layer. Adds a bit of variety. That's part of the actual landscape material all around. Okay, so if we take all of these layers, we can preview that. They're currently being pulled in by this node because that's what this node does. In its default import mode, if it's set to import mode, it's going to pull in that data from the BGO file. Now, at this point, we've configured this so we can pass it through to the next node in line, which is this landscape multi-split. Now, at this point, I don't want to edit all of my landscape. I'm pulling in all of my individual landscapes here, and I'm merging it together. So here you can see we're pulling in the height fields from the beach right here, as well as the center landscape, so landscape 2 and landscape 1. And I'm also pulling in their tile grid data, which is used to line up all the tiles internally for some of these other nodes. Now, if I want to only edit one of my 2 landscapes, what I can do is add a selection bounding box to this input here. And because I'm only grabbing the tile grid data from my left landscape, and I have a certain selection range of 100 meters from the bounding box, I'm going to grab all of the tiles of landscape 2, as well as these extra tiles along the border of landscape 2, which in this case are part of landscape 1. So we have an expanded little section of land that's being added to our data set. And I need that because ultimately, if I'm going to stamp in anything right on the border of our 2 landscapes, I want to make sure that I'm including just a bit of extra overlap so I don't have any artifacts or bad stamping. I don't want to create any kind of seams between our landscapes or weird ridges, right? Now you'll also notice that over here, I also have filtered out a certain set of layers that I want to actually edit. Because that's another thing this landscape multi-split node is very useful for. It is able to isolate out the layers that we actually want to manipulate. Having less data passed through the system, here on the left for terraforming, for example, is much more efficient. So this node is not just cutting out the tiles that we need, it is also isolating out the layers that we need. And then all the other layer data is going to go through this red channel. Okay, so this one only contains the data that we want to use, this one doesn't. Now in this case, all of the layers that I want to manipulate are either the height layer, which is currently set to be the procedural layer for editing. If we look over here, it's set to be the procedural layer, and we are purging it. So we're basically rewriting the procedural layer from its entirety from the start of these nodes. Okay, if there was already a procedural layer present, which in this map there is, right? It includes all the roads and such that were currently already in the map. We don't want to take that data, we want to replace it. So this node is going to recreate that data set. We're going to take that, purge the procedural layer, and feed it through here as height. Next to that, we're also going to contain the non-weighted material layers, because ultimately the road materials in this map are all non-weighted materials or layers in our landscape material that overlap the weighted layers below. So if there is a procedural layer present somewhere, a road layer, for example, or an asphalt road, let's say these guys, these are not weighted. They are basically overlaying all of our other materials in the landscape. So we want to include only our non-weighted material layers. And finally, we have the visibility layer, which we need for the tunnels, for example, right? We have a couple of tunnels in our landscape, and we need to have visibility state for that. So we can say tunnel underneath the map. All right, so let's pass this data through using the blue channel. And the first thing we're going to do is take some data from our recombined paths nodes over here, which are pulling in our road data. And then on this side, I'm going to create a couple of stamps specifically for the tunnels. So in this case, I simply create a couple of outputs here. Not all of them are visible. So if I grab a null node, for example, here's a shape for the tunnel. Here's some shapes specifically for terraforming in the tops and bottoms of the tunnel entrance. And this here is the visibility section for the tunnel we're using down here. So this information is passed through to these weighted height transfer nodes. So let's let those run. So the first thing we're going to do is terraform in the entrances for our tunnels. Now you might notice that even though this stamp here is overlapping part of our terrain, it doesn't terraform from this blue section. And that's because this is using the limit terraforming attribute. There is actually an attribute that we can also use here to limit how the stamps influence the surrounding terraforming. And the limit terraforming attribute, in this case, either terraforms only up or down. So that's what this blue one's doing. If there is ever a situation where the terrain is below the level of the tunnel, it's going to terraform it up, but otherwise it's going to leave it alone. These white areas, on the other hand, are instead terraforming both ways, both up and down. Okay, then let's feed it on. This one is going to refine our tunnel entrance just a bit more. That makes it a bit sharper. And then next up, we do the same thing for our bridge heads. So let's find our bridge here. It should be about this area here. This guy is going to terraform in the bridge head sections, and you'll notice how this line is red. That means it will only terraform down. Again, I'm using an attribute present on the input geometry that's telling it to only terraform down for this section of the bridge, whereas the entrance of the bridge, here the bridge head, is terraforming up to its level. And then finally, let's add in the roads as well. But for those, I need to create a mask to ensure that I am not going to override those sections of terraforming I've just created. So we're going to leave the entrances of our tunnels and our bridges alone. And then here, we're just going to run that weighted height transfer for the roads again. I already showed that earlier. But since we're using the interior fall-off option here, as well as a low subdivision input count, we shouldn't use too much memory or time to compute this. So overall, this should create a good result for our terraforming with less overhead. Okay, so at this point we have done all our terraforming. Now let's apply our materials next. And for that, we're going to look at one more node, the blended material transfer node. Now, first thing we need to do is set up the visibility for our tunnels. So if we go over here, again, we have a setup material mask. And then this node is going to create the mask for the tunnel entrances. So once again, it's going to basically handle this invisibility state for our tunnels. We need to apply this to our terrain. And for that, we are going to use this blended material transfer node. Now this node is able to write to the different material layers in our terrain. Now at the moment we are writing to the visibility layer, which is a unique layer that is part of our landscape material. You need to set that up, and it's a default variable, a default layer that should be present if your Unreal terrain has a particular node inside of the landscape material. You can check out the landscape material at your own time inside this project. It's pretty easy to find. Then I'm going to set it to replace, meaning that I'm basically replacing the current visibility layer with whatever data is coming on from here. That does mean that if there's any visibility painted into the terrain already, it is going to override it. So you want to keep in mind how you set this up, or when you stamp this into your terrain, you might override someone else's visibility painting, right? If you don't want to do that, alternatively, you could also use the option here, max or add. If you use max, it's going to take whatever visibility state was already coming in from here, from the PGO files, from the Unreal extract, and it's going to add to it. But just keep in mind that this does mean that if you've moved your roads and your tunnels are somewhere else, it is going to keep that visibility layer in the same place, and you're basically just going to add to it. So you might have to do a bit of post cleanup yourself. Regardless, I'm going to leave it on replace at the moment. And then next, we need to apply our road materials. So from our recombined path nodes, I can grab the road hulls. I can isolate out, say, the asphalt meshes. So here are the asphalt roads. And I'm going to create a mask for them. Let's do the same thing for the dirt roads as well. And for those, I've added in just a bit of edge noise, so you get this bit of feathered effect. It makes the dirt road just a bit less straight. This is especially noticeable on some of the thinner roads over here. If I were to disable the edge noise, it's going to make them just a bit straighter. Anyway, let's grab this and let's feed this into the system here. And we're going to ignore this setup here. This is just an example for custom layers. Over here we have the dirt road. Let's stomp that in. Again, take the procedural dirt road that's currently present in our data here, and we replace it. Let's do the same thing for the asphalt roads as well. And then finally, I want to make sure that anywhere there's a road, I'm going to forcefully remove the grass as well. So this one is going to write to the remove grass layer. Now that's using a combined set of layers, so I combine these two together using this height field layer blend node. Then finally, let's add the darken layer and subtract the roads from it. So over here I have this setup. This does take a bit of memory to compute because I'm basically computing out a new darken layer in its entirety. If we run that, you'll notice that it adds those extra splotches along the hills. You saw that earlier. Like, that's basically these sets of dark stripes on our terrain. Adds a lot of definition to the terrain. It's quite nice, so I like to add that. But if we're, moving our roads around, we might need to recompute this. So there's an option inside the system to do just that. And that's going to replace the darken layer right here. And then finally, just to make sure if we have any roads that cross some parts of our terrain, I don't want to have the darken layer override those. So I'm going to subtract those. Right. So here you can see the dirt roads remove some of it, whereas the asphalt roads will remove all of it. That's being handled by this height field layer node. Okay, so with that set up, we can now bring this back, combine all our layers back together. If we zoom out here, let's render this landscape multi-splice node. And what this node is going to do is it's going to take the data from the left, which we were editing, and it's going to take the red channel here, which is the inactive data and the inactive tiles, and it's going to combine them back together again. So now we have combined our layers, and if we look closely, you can see that it's also split our height fields back up again into individual data sets. So we have one for the left channel for landscape 2 and one for landscape 1. Now next up we have again two process and export tiles nodes. Let's have a look at the landscape 2 node. If we look at this node, you'll notice that it itself is only processing the left landscape. It has completely ignored the other one. Okay? That's because internally it's being told to only load the landscape 2 by its name here. When you set this node in composite and export mode and you feed it a project name, it is going to only isolate out that project name's data. And this node has split up that data so it can be isolated out. That's the gist of it. Okay, so what is this node doing right now? In composite and export mode, the process and export tiles node is basically grabbing all those edit layers and it's recompositing them. So Unreal can use that for its height maps, right? We have the different edit layers, which comprise different states of our height map, different components of our height map. And we have all of our material layers as well. If we look at our edit config and we look at the preview layer for our height, we can actually look at the individual edit layers right here. So we have our base layer, which is the landscape without any of our terraforming. That's our base height. Then here we have the macro layer. This is where your artists can potentially stamp in their own custom edits to the terrain that aren't part of the base terrain. Then we have the procedural layer, which contains all of our modifications to the terrain, all of the, let's say, roads here, and their modifications either up or down in relation to the other layers before it. And then finally, we have the micro layer, which is where your custom edits are going to be stored, right? Any final height changes that we might want to make to our terrain to fine-tune the result. Okay, if we combine those together, we end up putting them into our composite layers. So if we look at the composite post-procedural here, that's going to give us our road terraforming and basically all the layers combined. Now, what we can do next with this is either render it out as tiles. So if we look at the render tiles option here, we can actually go in and batch render out all the tiles for this landscape here. And that's going to end up directly into, our tiles folders. And we can then apply that straight to Unreal. But what I want to do next is actually set this up to be used in the PDG and to continue editing on this landscape in a subsequent node. Now to do that, I had to set up a little system here to pull out the data of my landscape so we can be pushed forward into the next node. And alternatively, if we want to render it out the tiles inside the PDG, I pulled out some information from the PNET nodes here, and these are actually layered nodes. If we go inside, you can actually see that there is a section of nodes in here around the core of the PNET node, and the node that we can pull data from is the layers to render right there. So currently, what this guy's doing is it's exporting out all of these layers that you might want to render out the tiles, and that can then be sent to the subsequent batch renderer node, which will handle all the tile creation. Okay, so we can choose either to render out tiles from this result, or we can choose to continue editing it by feeding it to another terraforming network like this. Okay, so let's go out of this network now that we have this computed, and we're going to feed this out to a geo file when we run this in the PDG, and then this node is going to pick that up and it's going to start processing it, or let's say post-processing it. So let's have a closer look at this next node in line, which is the PDG example workshop mesh stamp. If we go to this node, then you'll notice that in here we actually have a similar setup. We have an input with PNET nodes, and we have an output with PNET nodes. And then in between, we again have some landscape multi-split nodes and multi-splice. And then in between that, we have the terraforming setup. This is where we're manipulating our data. This is where the input is, and that's the output. So what are we doing here? Well, in the previous node, these particular PNET nodes were set to export mode, right? So we go to input, they're set to composite and export. This means that from their outputs, it's basically, after it's composited our edit layers, sending the data back out for further editing. Now in our edit config, I've told it to set the active layer to procedural layer, and it is not being purged this time because I want to continue modifying it. Now this has prepared the data for further editing, but just in case, I've actually repeated this setup right here. I'm pulling in my combined landscape data and the tile grid data as well. I'm splitting it back up, unpacking it to make sure that the data and the attributes don't get mixed, right? That's the useful thing about packing. And then these process and export tiles nodes, again, are going to grab that data, split it up by the project name, and recomposite it again. This is just to prepare the data back for editing. It doesn't really do anything else. Okay? Pretty straightforward. Same thing we did before. Now again, under Edit Config, we are writing to the procedural layer with purging disabled. So at this point, we basically have the same setup as what we had in the other node, except this guy isn't loading from the BGO file, it is loading from its inputs. Okay, so again, we are only editing landscape 2. So this landscape multi-split node is going to split up our data, and again, only grabbing the left landscape. Now you will notice that in this case, I do have my weighted material layers selected as well, meaning that from our active blue output here, I am actually pulling more layers. Now this includes a lot of extra material layers because ultimately, if you have a weighted material, that means that it's going to weigh against every other material in the set. So every single weighted material has to be included, or this won't work properly. Okay, so what are we going to do with this data now we have it? Well, the first thing we need to do is retrieve all of those stamps that we created previously. So if we go to our cache, we go to mesh stamps, we want to grab all of these files here. To do that, let's run this Python script. Now what this Python script here does is it samples the folder provided down here, which is our cache folder. If you want to look at this closely, this is the cache directory attribute, or parameter rather, provided on top of our interface. And then it's going to search that folder for all of its subfolders. Now, in general, that's going to mean that from here, it's going to find these two folders. Then it's going to do another search inside of those for any files and folders it finds here. And it's going to look for a folder called mesh stamps. And then inside that, try to find every file present in there. So if we look in that, we go inside the mesh stamps folder, it's going to locate these files here. Now, that's all good and well, but of course, we do need to filter out for, specific files. Because if we weren't to do that, and there was some random file in here, like let's say a text document, then our file node down here wouldn't know what to do with it, and it might error out. So down here at the bottom, I have a simple filter, which is going to look for the extension of the files, and it's going to filter for the .bgo file format and the .sc extension. Since all our files here are bgo.sc files, it should find these guys and accept them, but it will ignore the text file. So if we have a look at that, you'll notice that now this loop here is loading every one of the files that it's found. So that's the two stamps for this landscape and the one on the other landscape here on the right. Now, if you don't have this filter, or let's say we also allow it to find the extension .txt, then in this case, this file node is going to error out because it doesn't know what to do with a text file, right? The txt file is not accepted by the file node. So just in case, we have this filter here. Now, if you have a lot more caches, you'll want to set up a more complicated filtering system because ultimately, you don't want to pull in massive quantities of data especially if that's heavy data. This is not super heavy, but if you have additional sets of data in here, or let's say multiple generations of data and you want to filter out for specific data sets, you might want to include some detail attributes or groups or something in your files and then filter that out before you go and load it. There's actually a way how you can do that. If you set this node here to load in only, let's say, info of your files, then over here it will pull in information about, for example, which point groups are present or which attributes are present on your data. Like here's the attribute summary. You could add some attributes in here with a prefix name and then filter by that. It's actually a trick you can do, which would allow you to only load the data from the files that you need and then have another loading loop for the actual file data. Just something to think about. But anyway, now that we have our stamps, let's go ahead and apply this. Okay, so here we have the main channel for our landscape. I'm going to add a new layer called custom mesh stamp right here. And then next we have a loop, and this loop is going to run over every single point that we're providing from this network here. We're going to identify how many stamps we have by setting an ID on them. And then we're going to just run, let's say, the amount of loops that we have IDs to sample. Okay, so we have 3 stamps, so we're going to run 3 loops. Then over here, we're going to grab our current stamp by isolating out the current primitive by its ID. Okay, so in this case, that would mean we are applying this stamp next. Then over here we have a volume height wrangle. Let's call this one apply stamps. And this one is first going to save the current height of our terrain to a local variable called original height. Then next, we're going to sample the height from our current volume, assuming these 2 volumes are at the same height level. They do need to be at ground level at height 0, or this won't work. But the volume sample script is simply going to grab for each pixel of our main terrain, and it's going to stamp into this landscape. Okay, that's going to write directly into the height of our landscape. Now at this point, we do need to make sure that we don't override our entire height map, which is why we're also going to sample the alpha layer, and I'm going to write that to this custom layer called mesh stamp, right? Custom layer mesh stamp. So if you have a quick look at that data, that's basically the alpha layer mask that we are grabbing from here. So I could also go over here to the right and instead sample the alpha layer. That's basically doing the same thing. So we're copying the alpha layer from here and then sending it over to this side as the custom mesh stamp. All right, we're going to use that and use a linear interpolation between the original height of our terrain, the height that we had before we applied the stamp, and our current height. And that's going to return a new height for us. So we're basically blending the stamp that we just applied to our terrain here with the surrounding terrain that we had previously before, this iteration of the loop ran. If we don't do this, then we're basically overriding our height entirely, and we'd only keep this around. So this is necessary. And then finally, we also have the material that we need to make sure we apply that's below our buildings. So that we're going to write directly into the mask. Now next, over here, we have another set of blended material transfer nodes. Now these nodes, in this case, are writing to a weighted material. So what this is going to do is it's basically going to take our existing layers and it's going to subtract from them to add back in the material for underneath our buildings. We're going to write into the dirt layer in this case. But notice how I've set it to max, meaning that whatever dirt layer was present in the previous iterations, it's simply going to add to it and keep the maximum value. So what that means is any dirt layer that was already written into our map is going to be kept, and we're going to add to it for every single building footprint that we're adding in this iteration of the stamp, and then next, and then the next. Let's do the same thing for our remove grass over here. Now in this case, I don't want to mix it up with my dirt layer. If there's already a dirt layer present, I don't want to always remove my vegetation, right? So I'm going to make sure this one isn't actually outputting its mask. So it's just going to pass through whatever mask we were trying to write in from here. And it's going to add it for the grass as well. Alternatively, if you want to secure this, you could also plug it in like so, and then set this node up to use input 2 instead. Then it doesn't matter what this node is outputting as its mask. Just a precaution, because ultimately we don't want to start mixing up our data, right? Because this one has a different set of data already. This one already has the remove grass assigned on its roads, and we don't want to mix that up with our dirt layer. And then finally, let's make sure we add together our mesh stamp custom layer. So what that means is take whatever mesh stamp layer we already had at the beginning of this loop. Since this thing runs 3 times, it's already run 2 loops. We're looking at the final loop here. Okay. So here it's already stamped in these 2 towns. We're going to add to that by stamping in the current mesh stamp layer as well. We're going to add those together using add mode. Alternatively, you can use maximum mode. If we look at that, now we have all our stamps that we've currently applied to our terrain as a custom layer that we can use for other tools. This is very useful because ultimately, let's say you want to know where your mesh stamps are. You can use these layers with a load layers node, for example, and sample it for your tools to use. And of course, you can use this for your own creations. Ultimately, this is going to be written out to a tile, right? This is another custom layer that we've added. So in our data set, we now actually have a layer called custom mesh stamp. And if we were to look at our output here, let's go to landscape 2, and then let's find the layer custom mesh stamp. Then in here, you might find a stamp for one of your towns. Now in this case, I don't have all the towns included in this data set because previously this node was set up wrong. But basically, if we were to stamp this out now, it would include every single town in our layers, and we can use that. Okay, so at this point, we are pretty much ready. Let's go and feed this back together. So I'm going to take this landscape, combine it back with the other landscape and all the other edit layers that we filtered out previously. And let's feed this back to our PNET nodes. So again, this is going to composite our procedural edit layer. And if we have a closer look at that, you can see here that the dirt layer has been subtracted from our forest layer in this area. Same thing for here. Likewise, we can have a look at the, let's say, procedural roads, like this guy. We have our mesh stamp layer right there. And finally, we have the dirt roads, right? And with that, we can now go ahead and export this out for Unreal to use. So if we go back to our parameter interface for this node, you can see that this one is going to be configured as PDG output to tile render. That means that we're going to use this side of the network. It's going to pull in our terraforming data, our layers, and those layers are then going to be fed down the network to the output node, to the batch render node. Let's look at the network here. It's going to collect up all the layers, go through the network, and then finally it's going to run them through the batch tile exporter, which is going to output it to our tiles here. So that's basically it, because at this point, you've already seen how everything works. I know this has been quite a long lesson, so I'm just going to finish this up. Let's say we save all these nodes here, make sure any changes that have been made, in my case, are saved out. And then let's run this one last time in Unreal and stamp this in. All right. And let's also make sure we've saved this node here. And now that I've saved all of my nodes, I can go back to Unreal, go to the Task Manager, or of course we can go to Houdini and do it there. So in this case, I'm going to go into Houdini so you can see this running live. Let's go over to the Task Manager for the workshop, make sure all of this is set up properly, including the paths to our HDAs. So just set this up first. Reassemble our file paths. This should feed this in. And then we can say, let's say reset PDG. And then PDG render. If we do that, we jump inside the network. Then it should now start computing out these nodes one by one. Now this is going to take a minute, especially for the terraforming stages for the roads. So what I'm going to do is pause the video every time it's computing, and then you're going to see it progress through, so you don't have to sit through this waiting for it to finish. Now incidentally, you'll notice that it is building up memory, and like I mentioned, because I've staggered the process, this will take some memory for each step, and then it's going to let it go because it's going to purge this particular node out of memory and then move on to the next one. Now you might notice that it's using a lot of memory. In this case, that's probably because I'm running both Unreal and this system at the same time. It's all taking up quite a bit of space, so take this with a grain of salt. But the main idea here is that I've staggered the process so you can compute it in batches. And you just see that it just dropped my memory quite far because this node just finished and it's passed it off to this guy down here. If we have a wait and see, this one should finish pretty soon, and then it's going to pass through and start on landscape 2. Alright, so now it's done with these guys. And then notice how it's going to create a bunch of tasks here, one for each layer in our terrain. If I actually look at the info on these guys, you can see that it's outputting, in this case, the snow material layer. Right? That's one of these tasks. I can maybe flip through some of them. So this is the composite pre-procedural, darken layer, custom mesh stamps layer. You know, all of these are present in this data set. And then if we wait for this setup to finish, it's going to do the same thing here and then pass it on through to this compute tiles node. So stand by while this finishes. And now that's finished. And there you see, now it's going to just propagate through the network and it's going to start rendering out my tiles. So this is the batch tile exporter. It's currently told to export, I think, about 80 tiles per batch. And as it goes through this, you'll see all these dots filling out. So those are the tiles that are currently being rendered. Let me just inspect one of those. This would be a cliff material. This is grass, dunes, all of these. And if we look in the tile folder, let's find the darken layer, for example, again. And here you can see our timestamps. As these files are written out, it's going to start updating them and overwriting them. Okay. Now this shouldn't take too long, especially if you put enough cores on the job and you are allowing it to write out enough sets per batch. The main bottleneck here is how much memory and CPU you can ultimately spare for the rendering process. Otherwise it doesn't take too much time to compute this out. So once it's done with that, it's then going to wait for all these tasks to complete, and then it's going to pass it on to the next set. Now you might notice I have a couple of Python nodes set up here. That's actually giving me a readout. Unfortunately, this is a Houdini only, right? But this will tell me when certain stages of this node are complete, so I don't actually have to go into the node and visually wait for it to finish. Okay, so that's finished. And now finally it's going to do those overlap tiles as well. So this is going to compute the overlap tiles between our different landscapes. Again, it creates a bunch of tile tasks, and that's going to render those out as well. In fact, if we go over here, we could probably see it writing out some of these files. If we just wait for a sec. Here we go. So you can see some of these timestamps are going to start updating as it finishes the render task. Alright, so that's all done. And with this rendered out, of course, we should also now have all of these layers present in our mesh stamps layer. Let's find that. If we look here, you can see we actually have both of our mesh stamps included, because previously that wasn't the case. Now the tool's been updated, and you can actually see this, that both of our towns are included on these tiles. Same one for landscape 1 as well, over here. There's this town as well. Now with this, we can go back to Unreal and apply this to our map. If you've customized your own towns, now you've output this, you can go back in and stamp it into the world, right? So if you want to apply any changes that you might have made, you go back to landscape mode. We go to manage, import. Then we need to say import the height map for the procedural layer. So let's say landscape 2 procedural layer. Open that up. Let's make sure we're writing this into the correct landscape, because at the moment this is assigned to landscape 1. We need to write this into landscape 2. And let's scroll down and make sure we select the procedural layer so we don't overwrite the wrong layer. We actually want to apply this to our terraforming and nothing else. Let's import that. Now, because I've made a couple of changes to my terraformer, some of its settings, you might have noticed that the terrain just slightly updated. Not much, but you know, just a bit. But if you look at it and we hide all of our mesh shapes here, then you can see that our terraforming should be correct and our buildings are sitting nicely on top of the terrain. We don't have any intersections between them, so that's all working just fine. And of course, if you want to apply some of your materials as well, then go ahead and import those as well. But of course, you won't see much difference to the materials because I haven't really changed those. But if we go back and we view all of our tools here, you can see that the stamp actually does line up with our terrain properly. So our recent terraforming changes and whatever changes I just made have been applied. Anyway, that's pretty much it. Go ahead and experiment with these tools. And of course, make your own tools. Like if you want to, you can start testing and modifying the foliage spawner, for example, or try to make some more advanced road decoration, like maybe add some road stripes or something for the roads. That would be nice. But with this, yeah, we're pretty much come to the end of this workshop. So let me go to the slides and finish this up. So that's a decent overview of the current features that are available in the toolkit. There's the bridge and tunnel tool as well. There's multiple different subcomponents that I haven't really gone into deeply. But when it comes to creating your own tools, the ones that I've just shown you are probably some of the most important ones. That said, I'm still working on the toolkit and I'll be continuing its development. I'm working actively on the vegetation component, how to properly output vegetation. I'm looking into including PCG in that process as well. I'm also looking into render farm support as well as Perforce integration, so the system can automatically check in and out files. You know, you don't have to worry about handling that yourself. The system could do that for you. I'm also working on a terraforming toolset, which if you actually look at the example project, half this landscape was sculpted using an advanced terraforming toolset that I haven't even released yet. So that one's currently in the pipe. And then finally, I've got a couple of other things that I want to integrate, such as potentially material ID, something that they recently showed in Project Pegasus, right? As well as other systems, just to making massive open worlds even easier. Now at this point, I can at least assume that you're interested in the toolkit, because you've made it this far into the video. And if you have the Patron subscription, then it will come with a Tier 0 license for using the toolkit for non-commercial and limited commercial use. However, do keep in mind that if you surpass a certain amount of income on your project or your company, then you will have to buy a license from me, from the website, to be able to keep using the toolkit. In that case, please go ahead and visit my website at ehoudiniacademy.com/licensing, and you will find all the relevant information about licensing there. If you want some of my other videos, you can visit my YouTube channel, E-Houdini Academy, or you can go to my website and learn more about the masterclass. This is currently on hold while I'm working on the toolkit, but I do plan to continue on it in the future when I find time again. I kind of have to pick my battles here. Now, if you want to talk with me, go ahead to my Discord and you can join me and 600 other people there. We generally talk about Houdini. If you have any questions, you can also go there. So go on and join the community. And then finally, I want to thank everyone that's been helping me develop the toolkit by testing it out. And of course, if you want to join my Patreon yourself, you will get access to all of these features here. You'll get regular updates on my Patreon page when I have something new to report. I have mentoring and student guidance on my Discord channel, dedicated channels for people who want to learn Houdini and ask me questions. Next to that, of course, you get the toolkit downloads, and occasionally I do a Discord live stream. So thank you everyone for following this video. I know it was a very long one, but I had to cover a lot of ground. And if you're able to follow along to the end of this video, you are a champ, okay? And if you're interested, go ahead to my Discord channel and contact me. I'm always willing to talk to people, granted I have time, of course. All right, thank you, and yeah, see you out there. Have a good one.